All right, so today I'd like us to go through probability one. Before we comment, please subscribe and also ask all your questions at the comment section. I'll be glad to answer them all. Thank you. Let's continue. Now, as we know, probability is the likelihood of an event occurring or not. Now, this likelihood, I normally refer it as chances. So, this likelihood, I refer this thing as chances. So the chance that something may occur or not. Now let's assume we have E to be event. So we are using E to represent event. Then it means that the probability of the event is equals to what? Number of events or number of sample space. So in this case, where X is what? The sample space. Now we have some basic laws of probability, and you just have to take these laws into consideration. So whenever you want to solve probability questions or you want to deal with probability, you just have to obey these laws, these four basic laws. Now the first one is saying that the probability of an event always lies within 0 and 1 inclusive. This means that whenever you solve probability question, just make sure that your answer is between 0 and 1 what inclusive. Meaning you can get 0, you can also get what? Exactly 1. But you cannot get more than 1. And you cannot also get less than 0. So your answer should be between 0 and what? 1 inclusive. Meaning if you are able to get something like 2, you are wrong. If you solve probability question, you get something like 1.1, you are wrong. If you solve probability and you get something like 2, you are wrong. If you solve probability and you get something like 7, you are wrong. The idea is whenever you solve probability question, just make sure that your answer is not more than 1. It's not more than 1, and the answer to is not less. That should not be less than 0. That's the idea. That's why you can see that mathematically we have 0 is less than the probability of the event and less than equals to what? 1. So it means that the answer should be between 0 and what? 1 inclusive. And again, I want to repeat, whenever you solve questions like this, always make sure you don't get more than 1 and also less than 0. Less than 0 means we don't have to get negative answers for probability. All right. The second law too is saying that whenever you find the probability of the sample space, the answer should be what? 1. So you can see that we have the P into bracket X equals to what? 1. And we call this thing sure or certain event. It means this thing, whenever you get to 1, it means that it's bound to happen. So it will happen. This thing will come to pass. All right. Now let's assume. Let me explain the two better. Let's assume we have 7 black balls, and we want to find the probability of selecting a black ball. Now here you can see that our sample space contains what? Black balls. And we also want to find the probability of selecting a black ball. So in this case, you see that our answer will be 1. Why? This is how the thing will be. So we have 7 black balls, and we want to find the probability of selecting a black ball. Now, as I said from here, probability means what? Chances, not selection. We have to take note of this. Probability is not about selection, but it's about what? Chances. The chance that something may occur or not. So if here we want to find the probability of selecting a ball, though we want to select a ball, it doesn't mean the probability should be 1/7. No, we just want to select a ball. So just find the chances that this one ball will be selected. That's the idea. Now, when you're about to select that one ball, you can see that each of these 7 balls has a chance of what? Being selected. It means that the chances there is what? 7. So the chances there is 7. Then the total number of balls there too is what? 7. So it will be 7 on what? 7. And this will give us what? 1. So you can see that we are getting what? The 1. And again, let's assume we have something like 5 5 red balls, and I want to find the probability of what? Selecting a red ball. Now, when you're about to select this red ball, how many red balls do we have? We have 5 red balls, meaning each of these red balls has a chance of what? Being selected. So it means the chances there is what? 5. Then the total number of balls there too is what? 5. So you see that when you cancel, you get what? 1. So even if you want to pick 2 balls or something with or without replacement, you still get 1 because we are referring to the same color there. The sample space is having. So we have 7 balls and we want to select a ball. So you see that the sample space is talking about what? Black balls. And we also want to find the probability of what? Selecting a black ball. So black ball, it means that we want to find the probability of the sample space. So it means the answer must be what? 1. And this is how we can get it. The chance is over the sample space. The chance is over the sample space. So as I said, if you have 7 black balls, the probability that this black ball will select a black ball, it means that when you're about to select, how many black balls do we have? We have 7, and each of them has a chance of what? Being selected. It means the chances there is what? 7 over the total number of what? Which is also what? 7. Then you get your answer to be 1. Okay, so again, the third law is saying that the probability of the null event is what? 1. So let me come back to use this 7 balls again. So let me use this 7 black ball. So we have 7 black balls, and we want to find the probability of selecting what? A red ball. Though we have only 7 black balls, so we want to find the probability of selecting what? A red ball. Do we have a red ball here? No. It means that when you're about to select this red ball, we don't have a red ball. So the chances there is what? 0. And the total number of red balls there, the total number of black balls there too is what? 7. So this will be chances over what? 7, and this will be what? 0. Again, let me use this one. So here we have 5 red balls, and we want to select or want to find the probability of selecting a green ball. Now, do you have a green ball there? No. But we want to select a green. So when you're about to select a green ball, we don't have a green ball. So it means the chances there is what? 0. How many balls do we have here? 5. So it will be over what? 5. That's the sample space, and this will finally give us what? 0. All right. So this is how we can also explain the third law. That is the probability of the null event is 0. So this event, we call it impossible event. Impossible event, meaning this thing will never and ever happen. All right. Therefore, the probability of an event occurring and not occurring sum up to 1. Now, let me alert you on this. The total probability is 1. That's why even here we said we can't get more than 1, because the total probability itself is what? 1. So you can't get more than the total probability. So the probability that an event will occur and the probability that an event will not occur, that's why we have the not at the top there, is equals to what? 1. We all know that for each tryout or experiment, we have 2 outcomes. Either you fail or you pass, good or bad, boy or girl, woman or man. So you can see that we have 2 outcomes. So if you add the probabilities of what? These 2 outcomes, the answer must be what? 1. That's the idea. So in this case, we can say that if we know the probability that an event will occur, and we want to find the probability that an event will not occur, it means that we can just group light, and or let me say you can make this one the subject, send this one to the other side. So this will be P E naught equals to 1 minus, then this one will be what? P E. So if you want to find the failure side or the probability that an event will not occur, it means 1 minus what? The probability that the event will occur. And again, if we want to find the probability that the event will occur, and maybe we have the probability that the event may not occur, so that one too will be what? The PE is equals to what? 1 minus this one to go and subtract. So we have minus here. Probability that the event will not occur. So in each case, is whether you want to find the failure side or you want to find the success side, you can see that it's still what? 1 minus. So we can now conclude that if you want to find the success or the failure side, it's always 1 what? Minus. So it's always 1 minus the probability given in the question. So this is how we can deal with things like this. Let's note that the probability that an event will not occur and the probability that an event will occur always add up to what? 1. So if you want to find the one side of the probability, you just have to subtract the other one from 1, then you get whatever you want. Now we can use this example. Let's assume we have this. Let me use this. Let's assume we have this. Let's assume we have this. Okay. Let's assume we have the probability that Kofi will pass an exams is 1/3. Find the probability that Kofi will not pass the exams. So here we have the probability that Kofi will pass what? The exams, and the probability that, we want to find the probability that Kofi will not pass the exams. So from our previous laws, we said that the probability of something occurring and the probability that the thing not occurring add up to what? 1. So if we have the probability that Kofi will pass an exams to be 1/3, it means that if you add the probability that Kofi will not pass the exam to 1/3, you get what? 1. So let me see if we have this. Let K represent Kofi. So to mean the probability that Kofi will pass the exams plus the probability that Kofi will not pass equals to what? 1. And from the question, we have the probability that Kofi will pass the exams to be 1/3. So plus Kofi will not pass the exams to be this. So now we'll group like this. This will move to the other side. We get the probability that Kofi will not pass the exams to be 1 minus 1/3. And this will give us what? 2/3. So this will be the probability that Kofi will not pass the exams. Alright, let's get another example. Now, the probability that Ama will not write an exams is, let me say, 2/7. Find the probability that Ama will write the exams. So we know the probability that Ama will not write the exams to be what? 2/7. And we want to find the probability that what? Ama will write the exam. So as I said, whenever you want to find the other side of the probability, you always subtract it from what? 1. So you always subtract the probability given from 1, and that will give you your answer. So it means that the probability that Ama will pass the exams, the probability that Ama will write the exams is equals to what? 1 minus 2/7. And this will give us what? 5/7. Alright, so we'll end here and continue in our other sections of the video where we'll be solving more questions on this. Thank you very much. Alright, so let's continue with our probability. Now let's assume we have the probability that Ama passed the exams to be 0.25, and we want to find the probability that Amma will not pass the exam. So that will what? Probability that A not is equal to, so this Amma will not pass. So that's why we have the not at the top there. And it will be what? 1 minus 0.25. 1 minus 0.25, because when you add the probability that Amma will pass the exams and the probability that Amma will not pass the exams, you get what? 1. So we are using this idea. If you have something like this plus this will give us what? 1. So if you want to find the probability that Amma will not pass the exams, you see that you need to what? Send this one to the other side just to what? Subtract. Okay, that's how we are doing this. And this will give us what? 0.75. Okay. And again, let's assume we have the probability that Rose will not write an exams, and the probability is 7 on 9. So we need to find the probability that Rose will write the exams, and that will what? The probability that Rose will write the exams, and that will still be 1 minus 7 on 9. So the idea is whether you want to find the success or you want to find the failure, it's always 1 minus the probability given. That's all. Okay. So again, let's assume we have two sets of people or individuals. So we have something like the probability that Amma will pass exams to be maybe 2 on 3, and we also have the probability that Kofi will pass an exams to be maybe 3 on 7. So we have the probability that Amma will pass an exams to be 2 on 3, the probability that Kofi will pass the exams to be what? 3 on 7. And we want to find these things. So we want to find the probability that maybe A, both will pass the exams, the exams, then none two will pass the exams. So we want to get something like this. See, maybe only one will pass the exam. Alright, so let's do this. So the idea is whenever you see this type of questions, I will advise you look for the opposite side. So here you can see that we have the probability that what Amma will pass an exams to 2 on 3. So find the probability that Amma will not pass the exams before you continue. So alright, the probability that Amma will pass to be what? 2 on 3. Meaning the probability that Amma will not pass will be what? 1 minus 2 on 3. And this will give us what? 1 over 3. And again, the probability that Kofi will pass will be what? 3 on 7. That's coming from the question. It's coming from the question. It's here. So the probability that Kofi will not pass the exams what? 1 minus 3 on 7. So this will give us what? 4 over 7. That is when you subtract this thing from this. Okay. So if you want to solve the first one like this, the first one to be probability for what? Both. For both, that will be what? The probability that Amma will pass and the probability that Kofi will also pass. So you ask yourself, what is the probability that Amma will pass? The probability that Amma will pass is what? 2 on 3. That's this. Sorry, this one. N means times. So when you are dealing with probability, N means times, all means plus. N means times and all means plus. So when you are dealing with probability, N means times and all means plus. So take note of this. N means times, all means plus. All right. So the probability that Amma will pass is 2 on 3, and so time the probability that Kofi will pass is what? 3 on 7. So this time this will go with this. You are left with what? 2 on 7. So this will be the probability that both will pass the exams. Let me do the rest here. So B, none Now the none means the probability that Amma will not pass the exams and Kofi too will not pass the exams. So you ask yourself, what is the probability that Amma will not pass the exams? It's here. The probability that Amma will not pass the exams is 1 over 3. So I can write 1 over 3 and so times the probability that Kofi will not pass the exams will be what? 4 on 7. So that one to 4 on 7. So if you multiply this and this, you get what? 4 on 21. That is this time, you get 4 on 21. The C aspect, we want to find probability that only one will pass. So only one. Now we are dealing with two people here, but the question is demanding for what? Only one passing the exams, and we don't know the person. So it can be Amma passing the exams or what? Kofi passing the exams. Now, if Amma passed the exams, it means that Kofi would fail the exams, and it means we can pick this as if only one. It means that Amma will pass the exams and Kofi will fail the exams, because if we have two people in the room and you just enter the room and say, okay, now these upcoming exams, only one of you will pass the exams. It means if the first pass the exams, the second would not pass, because you said only. Only means only one person. So you are dealing with only one person. So this one to what? Or Amma will rather fail and Kofi what? Pass. So it's either Amma passing the exams, Kofi failing, or Amma failing and Kofi what? Passing. So this is for only. So only one of them will what? Pass the exams. And note, you always have to, but don't write something like this because you want to get Amma pass. So you write something like this, they just leave it. No, always, because we are dealing with two people, we need to get to two sections. So let me say, sorry, two letters. So this and this in one section, this one to the same thing. All right. So the A aspect, what's the probability that Amma passing the exams is 2 on 3. N means times. What's the probability that what's the probability that Kofi will not pass the exams is 4 on what? 7. Okay. So cover it nicely. Plus, what's the probability that Amma will not pass the exams is 1 over 3 times the probability that Kofi will pass the exams is 4 on 7. As I'm taking the data here, we're using the data here. All right, so this time this will give us what? 8 on 21 plus this, and this will give us what? 4 on 21. So in all, we'll be getting this and this. When you add this and this, you get what? 12 on 21. If you can break it more, you can do it. If not, you leave it. But I think 3 will go into this 4, then 3 2 will go into this 7. So we are expecting something like 4 on 7. All right, you can try it on the calculator. You can key it on the calculator to check whatever you. All right, so this is the review of the probability concerning this type of questions. So let me get one question that we can use to solve all the other sub questions. Right. So we have a set of questions. The probabilities that Grace and Jane will pass an exams are 2 on 3 and 5 on 7 what respectively. Find the probability that both will pass, none will pass, only one will pass, only Grace will pass, at least one will pass, at most one will pass. So again, whenever you see this type of questions, please summarize your questions down. So I'll do this. So the question is saying that the probability that Grace will pass an exams is what? 2 on 3. So I'm using Jane for Grace, then J for Jane. So if the probability that Grace will pass an exams is 2 on 3, it means that the probability that Grace will not pass will be what? 1 minus 2 on 3, and that will give us what? 1 over 3. Always please try to do this before you start with the work. Alright, and the probability that Jane will pass is what? 5 on 7. So the probability that Jane will not pass will be 1 minus 5 on 7. This will give us 2 on 7. So this is a summary of whatever we have here. So please always try to get this thing down. It will make the work become very easy for you. Alright, so let's start. Now A, we want to find the probability that both will pass the exams. So it means that the probability that Grace will pass and Jane will also pass. So you ask yourself, what is the probability that Grace will pass the exams? It's here. It's 2 on 3. So you put it there, 2 on 3, and times. As I said, n means what? Times. The probability that Jane will pass is what? 5 on 7. It's here. 5 on 7. Sorry, no, it's here. 5 on 7. So that will be 5 on 7. You multiply and we'll be getting 10 on 21. Alright. Then a B. The probability that none will pass the exams. None will pass the exams means Grace will not pass the exams and Jane too will not pass the exams. So you ask yourself, what's the probability that Grace will not pass the exams? Is here is 1 over 3, and the Jane will not pass is what? 2 on 7. So we bring them here. So we have 1 over 3, then 2 on 7. And when you multiply this, you give it 2 on 21. Alright. Then the C aspect, only one. So only one will pass the exams. It means that if only one will pass the exam, it's either Grace will pass the exams and Jane will fail the exams, or Grace will fail the exams and Jane will pass the exams. So it will be Grace will pass and Jane will fail, or Grace will rather fail and Jane will pass. Okay. So Grace passing, we have what? 2 on 3. It's from here again. And so times Jane failing, we have what? 2 on 7. So 2 on 7. Cover it nicely. All means plus. Then Grace failing, we have what? It's here. 1 over 3. And times. And Jane passing is what? 5 on 7. Okay. So this time this you get 4 over 21 plus this will give us 5 over 21, and everything will be 9 on 21. And I think we can break it down further, and that's where I think 3 will go into this 3, then 3 goes to this 7. So the answer will be 3 on 7. Alright. So let's proceed to D. At the D aspect, we have only Grace will pass the exams. Now here we are dealing with 2 people. So assuming we have these 2 people in the room, and we just entered the room and say, okay, these upcoming exams, it's only Grace that will what? Pass the exams. It means that you want to tell Jane that Jane will what? Fail the exam. That is the idea. So if we have only Grace will pass, it means that Grace will pass the exams and Jane will fail the exams, because we said only Grace will pass, and if only Grace will pass the exams, it means that Jane will fail the exams. So Grace passing the exams, we have what? 2 on 3, and which is what? Times Jane failing the exams is what? 2 on 7, and this again will give us what? 4 over 21. All right. E. Now E aspect, we have at least one. So we have at least one. Now at least one means one or more will pass the exams. One or more will pass the exam. Now when it comes to the one aspect, it means that it's either Jane will pass the exams and Grace will fail the exams, or Jane will rather fail the exams and Grace will pass the exams, or both will pass the exam, because we want one passing or more. And one passing, it can be Jane and it can be what? Grace. Or more. More too, we are dealing with only two people, so the more will be what? Both. So it will be like Grace passing and Jane failing, or Grace failing and Jane passing, or both will what? Pass. So this is one aspect, and this is the more aspect. We are dealing with only two people. If you are dealing with three people, you continue. So it will be G and J, then the other ones will follow. All right. But with this, so you just have to put your probabilities inside to get your final answer. But whenever you see at least one, I will advise you to use the shortcut. So that at least one is the same as 1 minus the probability that none will pass the exams. So 1 minus none will pass the exams. We've solved this thing already. It's here. So 2 on 3. Sorry, it's 2 on 21 rather. 2 on 21. So when you subtract this, you get what? 19 on 21. So whenever you see at least one, you can use this method rather. Instead of this long method, whenever you see at least one, you can write 1 minus none. And if you don't know the none too, it means that you first have to solve for none and come and put it inside, then you get your final answer. So it's always 1 minus none for at least one. All right. The F. So let me solve the F aspect here. So the F, we want it to what? The probability that at most one. So the at most one will be the greatest should be one. So it means one or less. One or less. And when it comes to the one, it's either Grace what? Passing and Jane failing, or Grace failing and Jane what? Passing. Or the less will be 0. It means none will pass. So 1 or what? Less. So that will be right, that Grace will pass and Jane will fail, or Jane will rather fail and Grace will rather fail than Jane will what? Pass. Or we have Grace will fail and Jane will also what? Fail. So this at most one. So 1 or less. And the less is what? None. Because if you have 1 and less, the less is 0. It can't be negative. So the less is 0. 0 means what? None. Alright. So this will be what? You just put your probabilities inside, then that one too, you get your answer. And when it comes to this one too, we can also prefer to use the shortcut. That will be 1 minus both. So the probability that both will pass. Because I don't want to go through this stress, so I'll use this method rather. This one too works. So we have our 1 minus, and you ask yourself, what's the probability for the both? We've solved it here already. That's the first thing that we did. It's here. The answer is 10 over 21. So just come and subtract it from this. 10 over 21. And this will give us what? 11 on 21. So I think we are done with our question. And if you go through the solutions, you can see that all the answers, they are between what? 0 and 1 inclusive. None is greater or less than 0. So it's between 0 and 1 what? Inclusive. So you always have to what? Note this when dealing with probabilities. Thank you, and please don't forget to subscribe with pride. Please don't forget to subscribe. We'll be sending more videos on probability. So our next one will be the colors. And after the colors, we're moving on to the dice and the coins and the table probability. So please subscribe for these videos. Bye bye.